Welcome to JC Connect. In today's presentation, we'll be seeing the very important highway construction material, that is aggregates. These stone aggregates form the major portion of pavement structure, and they form the prime materials used in the construction of different pavement layers, that may be soft aggregates or the hard aggregates. These things we'll see and discuss in the next portion. These aggregates used in various pavement layers have to bear a different magnitude of stresses due to a wheel load, especially with respect to pavements. The aggregates of the pavement surface, especially surface cores, have to resist the wear due to abrasion action of the traffic, that is when the vehicle come in contact with the aggregates, that is wear, and deterioration due to weathering, and the highest that is magnitude of wheel load is transferred through these aggregates. And the stone aggregates are used in the construction of various pavement layers, as for example, if you see, that is bituminous pavement layer for in case of flexible pavements, or if you are taking CC roads, that is rigid pavements, in construction of cement concrete roads. There also it plays a very important role, and major percentage or portion of the concrete is made up with the aggregates. Then if you are constructing a cross drainage structures, or if you take lower layers like granular base course, or granular sub base courses, or lean cement concrete sub base, or as I mentioned, drainage layer. So like this, stone aggregates plays a very important role in the construction of highways. And to select these aggregates, we need to check the certain desirable properties of these road aggregates, and we need to conduct some basic tests that will discuss in the later stage. So just to go with the basics, these most of these aggregates are prepared by crushing the natural rock. You know, in geology I have studied, that is rock classification, as it may be igneous, sedimentary, or metamorphic rocks. uh, just to see, these igneous rocks are nothing but these are formed by cooling or solidification of this or crystallization of molten rock at different depths of earth crust. We can see the some of the examples. For example, uh, this ballast, basalt, and rhyolite. These are examples of igneous rocks. And if you are taking sedimentary, fine mineral fragments or fine particles of minerals or rock particles are transported by the means of water or wind and deposited to form sedimentary rocks. And uh, and the examples, you can see calcareous rocks like limestone, dolomite, and other silicaceous materials like sandstone. This and next is metamorphic rocks, and these metamorphic rocks, are formed due to recrystallization or modification of igneous or sedimentary rocks, and by it may be geological or natural agents, such as movement of rock beds, or temperature variation, moisture, humidity, or pressure, atmospheric pressure. And if you if you take the examples, uh, and that is slates, or marble, quartzite. These are the few examples of metamorphic rocks. right? So apart from these crushing of these parent rocks, we can get from the river beds also. That is, gravels are small rounded stones of different sizes, which are generally obtained as in river beds. And sand is we are getting due to weathering of rocks obtained on the river beds, used as fine aggregates. And we know manufactured sand, that is smaller size of crushed stones, we are getting at required sizes. We can operate and we can get it to the required sizes. But natural river sand, so yes, those are rounded smaller size of aggregates. And coming to this their properties, the what is the origin, what is the natural it's a source of rock. Based on that, properties will vary. And aggregates are specified based on their grain size, shape, texture, and its gradation, right? And this is also specified in various mm, uh, code books like IRC, Indian Road Congress, Bureau of Indian Standard, ASTM, and BIS, right? And next, coming to this hard and soft aggregates, as I was mentioning earlier, hard and soft aggregates. These for wearing course, we are generally going for hard aggregates. Um, that is for superior pavement types, and it is preferred to resist the uh, abrasion, crushing, and due to heavy traffic loads, it should not fail. So those are hard aggregates. And soft aggregates such as muram, kankar, laterite, brick aggregates, then slag, which have been used in lower layers of road pavement structures. In case of, say, low volume roads, soft aggregates or soft aggregates, or soil aggregates mixed. So that also can be used. Different set of tests and specifications are adopted for these soft aggregates. So in the next presentation, we'll see the desirable properties of aggregates. Just to revise, till now we had seen these stone aggregates have to resist the wear due to abrasion action and weathering action, and it need to resist the um, magnitude of heavy wheel loads, and desirable properties, that not in detail but portion, it is to what extent it is used in highway construction, that is for the wearing course, for the base, sub base, granular base, sub base, and even for the drainage layers. Then we had seen what are the sources, types of parent rocks, and if it is a gravel from a riverbed, we are getting different size of gravels, or smaller size of sand, we are rounded aggregates we are getting. Then it is mentioned in various um, codes also, like IRC, BIS, CSTM, Bureau of Indian Standards. Next, we have discussed what is soft and what is hard aggregates. So soft aggregates, generally we go for lower layers of the pavement, and hard aggregates upper layer. And if it is very strong, then we can go use it for the wearing course, right? So now we'll discuss on desirable properties of the road aggregates. So desirable properties, that let's start with the first, that is shape of aggregates, or in shape, as we know, as you have studied, different shapes of aggregates. It may be rounded, or it may be uh, conical, it may be elongated, it may be flaky aggregates, right? So out of these, which type of aggregates are most suitable? That is, it should be angular aggregates are most suitable. It should not be too flaky or too much elongated, so that will reduce the overall strength of the particular member for which we are using these aggregates. And next is adhesion with the bitumen. Yes, there should be a sufficient roughness on the surface of the aggregates. The aggregate used in bituminous pavement should have a less affinity with water when compared with the bituminous material. Otherwise, the bitumen coating on the aggregate will be stripped in the presence of water. Yes, that is true. Apart from that, it should rough surface will definitely give a good bonding between the aggregate and the bitumen layer. Apart from that, it should not be too much water absorbent. And next is durability test. The property of aggregate to withstand adverse action of weather is called soundness. Adverse, that is freeze and thaw, or it may be wetting and drying. Aggregates are subjected for completely two different conditions. Physical chemical action of rain, bottom water impurities therein, and thereof and that of atmosphere. Hence, it is desirable that the road aggregates used in construction should sound enough to withstand the weathering action. Yes, weathering action is because of the various climatic conditions that is subjected for hot sunny day. It is subjected for submerged condition during rainy season, and during winter season it is the night time it is cold, and during daytime it is completely hot. So because of this, the there should not be weathering action should not take place on these aggregates, and they should not reduce in size. They should not lose their strength. Next, coming to the next property, that is strength. Aggregates used in top layer are subjected to stress action due to traffic wheel load. As I mentioned earlier, especially as you go to the upper layers of the pavement, it should be very strong. It should be able to resist the wheel load. It should be able to resist the wearing action of the wheels. It may be rubber tires, or it may be metal tires, or heavily loaded vehicles may be running. So because of impact, it should not break, or it should not get crushed because of the resistance. So it should be strong aggregates. Next is hardness. The aggregates used in the surface course are subjected to constant rubbing and abrasion due to moving traffic. Yes, the so for this one particular test is there that we'll be discussing in later part. uh, hmm, the aggregate should be hard enough to resist the abrasive action caused by the movement of traffic. The abrasive action is severe when steel tired vehicles wheels move over the aggregates exposed to the top surface. Especially these steel tired, it may be construction equipments, construction vehicles, or it may be bullock cart with a steel rim. If it is moving with a heavily loaded luggage, then definitely that affects the aggregate. And abrasion, that is aggregate to aggregate, or aggregate to these steel metal tires. Because of that, it should not reduce the size, and it should not fail. That is hardness. For this, we will be conducting the specific tests. Next is toughness. The resistance of aggregate to impact is termed as toughness. So for this, we are conducting impact test, and earlier hardness. For that, we will be conducting abrasion test. The word impact means sudden application of load uh, for a very short duration of time. For example, if you are taking a hammer on the nail head, if you are hitting, then that's hitting part is very fraction of second, but the load transferred between the hammer to the nail head is very much, right? So that sudden impact. Similarly, in case of aggregates, also road aggregates, that because of impact load, the aggregate should not fail. Aggregates used in this pavement should be able to resist the effect caused by the jumping of steel tired uh, wheels from one particle to another at different level, cause severe impact on the aggregates. Yes, as I mentioned earlier, it is constructed in various layers, and all these layers, when especially in case of flexible pavement, heavily loaded vehicle is moving, then there is a load is transferred from grain to grain, in case of flexible pavement, and it is uh, affects the lower aggregates also, especially immediately after the speed breakers, or there is a pothole that time. So some situations may arise where there is an impact load on the aggregates, so that time the aggregate should not fail. And apart from this, as we can make a list like desirable properties like resistance to impact or toughness, resistance to abrasion, hardness, resistance to getting polished or slippery, or resistance to crushing strength. Then it should have a good shape factor. It should not be too flaky, too much elongated. It should not be too rounded. Smoothness. It should have a rough surface, and resistance to withering or durability. It should have good durable aggregates, good adhesion. So like this, we have discussed these desirable properties of the aggregates. In the next presentation, we will be discussing on some of the important tests on aggregate, like impact test, and then abrasion test, then this there may be uh, mm, crushing test. So like this, few important tests we'll discuss in detail. Thank you very much.